This hearing will come to order. Without objection, the chair is authorized to declare recess at any time. I want to say good morning and welcome to today's full committee hearing entitled Nature in Crisis, Biodiversity Loss and Its Causes. I'd like to welcome our distinguished panel of witnesses and thank all of you for joining us. Today we have the opportunity to discuss an issue that captivated the attention of the public and policymakers alike, namely the alarming loss in biodiversity that is occurring worldwide. As a matter of fact, I read a paper in France last week on this very subject. The Intergovernmental Panel on Biodiversity and Ecosystem Services, or the IPBES, recently published a summary for policymakers for its first ever global assessment report. This intergovernmental body, which is not a part of the United Nations, set out to assess the state of biodiversity, its ecosystems, and the essential services they provide to society. The global assessment was prepared in advance of the upcoming UN Convention on Biodiversity scheduled for 2020. I'd like to note that while we are primarily discussing the findings of the summary for policymakers today, the draft chapters of the full report were recently made publicly available. The final report chapters will be released later this year, and they will not differ from the findings in the summary for policymakers that we are discussing this morning. The findings of IPBES laid out are too stark to ignore. The global assessment lays out the direct drivers of biodiversity loss in the following order for the greatest to least impact: changes in land and sea use, direct exploitation of organisms, climate change, pollution, and invasive species. Though there are many underlying causes for these direct drivers of change, it is very clear that humans have had an outsized impact on our surrounding environment. We've already discussed the impacts that our changing climate is having on our oceans at our environmental subcommittee hearing earlier this year. But climate change as a driver of biodiversity loss also impacts non-marine ecosystems. I look forward to hearing from each of our witnesses about the real-world impacts of all of the drivers of this biodiversity loss. Much of the reporting on the global assessment has focused on the devastating findings that almost 1 million species could potentially go extinct in the next few decades. But we would be remiss if we did not discuss what else the report lays out, especially its recommendations for potential solutions and pathways for addressing biodiversity loss. I hope today's conversation with our witnesses will provide an opportunity to further illuminate potential solutions we can utilize to address the dangers highlighted in the global assessment. Earlier this year, I introduced the Energy Water Nexus Act with my friend and colleague, Ranking Member Lucas, to address issues related to water conservation and use in the process of Department of Energy's research, development, and demonstration activities. Cross-cutting initiatives like this bill are clear examples of the role that Congress, and especially this committee, can play in developing science-based solutions to our most pressing issues. June is World Oceans Month, and this week in particular is Capitol Hill's Oceans Week, or CHOW. I'm delighted that we have Dr. Porter from the University of Georgia joining us today to discuss the impacts of the drivers of biodiversity loss laid out in the IPBES report on coral reefs and the numerous ecosystem services they provide. Later today, the committee will be screening chasing coral, a film for which Dr. Porter was a scientific expert. The screening is free and open to the public, and I encourage everyone to come back and watch it. After the screening, Dr. Porter will host a question and answer session with the audience. I want to let everyone know that this Thursday, June the 6th, the committee will be hosting an Ocean Exploration Expo to showcase ocean exploration technologies. I again encourage members of the public and any of my colleagues to join this expo on Thursday. More information is available on our website. I would also like to welcome back Sir Robert Watson, who previously testified before our committee over 20 years ago. I am really looking forward to today's discussion to not only better understand the findings of IPBES Global Assessment Report, but also identify knowledge gaps, understand how best to implement the transformative changes recommended, and determine our path forward with science-based solutions. Thank you, and now ask Mr. Lucas for his statement.
Madam Chair, thank you. And before starting my statement, I'd like to take a second to recognize one of our senior policy folks, Ben Trainum, who's sitting up here with us. This is his last hearing before he leaves D.C. and returns to Richmond, Virginia. Ben's moving home to practice law, to grow his family with their second daughter due this fall. I want to thank Ben for his hard work. We'll miss that signature bow tie, even if it is kind of un-Western Oklahomish, and we wish you great success with your coming steps. So thank you, Madam Chair, for indulging me on that courtesy. Now, Madam Chairman, thank you for holding this hearing and providing a platform to hold constructive dialogue on this issue. And I'm going to read it one time, and herever after I'm going to refer to it as the report, the Intergovernmental Science Policy Platform on Biodiversity and Ecosystem Services. Oh my, what a mouthful. Global Assessment Report on Diversity and Ecosystems is a 1,700-page report that was just released yesterday morning. I'll be the first to admit to you that I've not read the complete report, and I admire any of my colleagues who found time to do so. The purpose of this hearing is to examine the report's summary for policymakers. And while I welcome today's discussion, I'd be remiss if I didn't say maybe waiting a week or so, a little time to read it in full and understanding of the process would have been useful, but those conclusions will serve us nonetheless. With what is being said, I look forward to a productive discussion on how we can use innovation to combat the most pressing changes in global biodiversity. Biodiversity, or the variability of species and ecosystems, plays a significant role in all aspects of human well-being. It's particularly important to agricultural producers who lead a system that feeds and clothes billions of people every day. The report ranks land and sea use at the top of their 5 biggest drivers of change in nature and concludes that agricultural expansion is the most widespread form of land use change. This expansion of agricultural lands is a direct result of the need to feed the growing population. The global population is on track to reach nearly 10 billion people by 2050, and the UN Food and Agricultural Association estimates that global food production will need to double by that time. Now, that's why we must support innovation and research that will help make food production more efficient and environmentally beneficial. Increasing production while eliminating waste of all kinds, including land waste, is a goal of any operation. The best way to accomplish this in agriculture is utilizing modern science and conservation principles coupled with proven management practices. The United States has been the model of conservation through voluntary coordination and innovation, and we must continue to carry that torch. Following the immense soil erosion and drought of the Dust Bowl in the 1930s, federal, state, and local governments partnered with producers to solve the disaster. President Franklin D. Roosevelt's administration initiated programs to conserve soil and restore the ecological balance of the nation, with producers leading the way. These U.S. programs and institutions that incentivize conservation have been incredibly successful and are still in effect today. We've also benefited from innovations like those of Nobel Peace Prize recipient Dr. Norman Borlaug, who developed varieties of semi-dwarf, high-yield, disease-resistant wheat. This variety's introduction in India and Pakistan during the population boom of the 1960s is credited with starting the Green Revolution and saving up to 1 billion people from starvation. There are even more exciting innovations on the horizon. Genetic engineering, gene editing have the potential to produce plant varieties that require less land, less water, less fertilizer, while increasing biodiversity. This next generation of crop genetics are closer than we think, and current investments in research will pay unmeasurable dividends in the future. One of our witnesses today, Dr. Jeff Goodwin, will discuss efforts at the Noble Research Institution to increase soil health and productivity through improved land management techniques. Mr. Goodwin will speak to voluntary agricultural conservation practices led by producers that should serve as a model for different industries. We've seen incredible success from these industry-led efforts without resorting to burdensome regulations. In closing, I'd like to remind my colleagues of this committee's jurisdiction. This topic walks a fine line with the Natural Resources Committee, so I encourage my colleagues focus on research and innovation that can be used as solutions, not the doom and gloom of predicting what might happen in the future. Too often, we are bogged down by the alarming negative headlines that stem from these reports. What I see is another opportunity to revolutionize. I see another opportunity for the United States to show yet again we're the best in the world at solving the daunting and complex problems we all face. I look forward to hearing more on technological innovations and environmental stewardship that looks to improve our critical biodiversity while promoting economic growth. Thank you, Madam Chair, and I yield back the balance of my time.
Thank you very much, Mr. Lucas. If there are members who wish to submit additional opening statements, your statements will be added to the record at this point. At this time, I'd like to introduce our witnesses. Sir Robert Watson served as the IPBES Chair from 2015 to 2019. He is a leader in the field of environmental science and has spent much of his distinguished career focusing on the impacts human activity has had on Earth. Currently, Dr. Watson is Professor of Environmental Sciences at the University of East Anglia in Norwich, England. He also serves as Director of Strategic Development of the Tyndall Center for Climate Change Research at the university. Dr. Kate Brauman is a coordinating lead author for the 2019 IPBES Global Assessment. Dr. Bowman also served as the lead scientist for the Global Water Initiative at the University of Minnesota Institute on the Environment. Dr. James Porter is an emeritus professor at the University of Georgia, Odom School of Ecology. Dr. Porter's research focuses on coral reef ecology and conservation, as well as marine life ecosystems. Dr. Jeff Goodwin is a conservation stewardship leader and the pasture and range consultant at the Noble Research Institute based in Ardmore, Oklahoma. Prior to his current position, Dr. Goodwin worked for the U.S. Department of Agriculture and Natural Resources Conservation Service for nearly 14 years. Lastly, we have Dr. Stephen Montfort. Dr. Montfort is director of the Smithsonian National Zoo and Conservation Biology Institute. He holds a PhD in environmental science and public policy, as well as a doctorate degree in veterinary medicine. Our witnesses should know that you each have 5 minutes for your spoken testimony. Your written testimony will be included in the record for the hearing. When all of you have completed your spoken testimony, we will begin with questions. Each member will have 5 minutes to question the panel. We will start with Dr. Watson.
Thank you, Madam Chair and members of the committee. I really appreciate the opportunity to provide this testimony, which is indeed based on the IPBES Global Assessment of Biodiversity and Ecosystem Services. As Madam Chair said, IPBES is an intergovernmental body, but it is independent of the United Nations. The assessment was prepared by 450 scientists. We used 15,000 sources of information and received 15,000 comments during 2 rounds of expert and government peer review. The chapters and the SPM are now all available on the IPBES website. Biodiversity, which is critical to human well-being, provides food, as indeed has been mentioned already, fibre, water, energy, and medicines. It regulates our climate, our air, our water pollution, storm surges, floods, and pollination, and has significant cultural and social value. Biodiversity is currently being lost at a rate unprecedented in human history, primarily driven by changes in land and sea use and direct exploitation of organisms, and to a lesser extent, to date, by climate change, pollution, and invasive alien species. These all result from increases in the number of humans, per capita consumption, trade, technological innovations, and governance systems, local to global. These losses in biodiversity are undermining human well-being, especially these regulating and cultural services. While climate change has not been the dominant driver of the loss of biodiversity to date in most parts of the world, it is projected to become as important or potentially more important than other drivers of change in the coming decades. Climate change is already adversely affecting genetic variability, species richness, populations, composition and distributions, and the boundaries, structure and functioning of ecosystems. These changes are evident and accelerating in marine, terrestrial and freshwater systems. Almost half of the threatened terrestrial mammals and 1/4 of threatened birds may have already been negatively affected by climate change. In turn, biodiversity can adversely affect the Earth's climate. For example, deforestation increases the atmospheric abundance of carbon dioxide, a key greenhouse gas. Therefore, it's essential that we look at the issues of biodiversity and climate change together. In addition to transforming the way we produce and use energy, there are many nature-based approaches that can be used to adapt to or mitigate human-induced climate change, large-scale reforestation, ecosystem restoration. However, it is important to recognise that some of the approaches that have been suggested to limit human-induced climate change, such as large-scale afforestation and large-scale bioenergy, will adversely affect biodiversity and food and water security if native vegetation, grasslands and forests are replaced by monoculture bioenergy crops. So we have to think through very carefully how we use afforestation and bioenergy. Loss of biodiversity, just like human-induced climate change, is not only an environmental issue, but it's an economic, development, social, security, moral and ethical issue. The loss of biodiversity is projected to continue or worsen in many future scenarios. Business as usual is not an option if the world wants to conserve and sustainably use biodiversity and meet sustainable societal goals such as food and water security. Scenarios show that the impact of climate change is projected to intensify with the degree of warming. For instance, in a climate change risk assessment, 5% of species are at risk at a 2-degree warming, rising to 16% with a 4.3-degree warming. Current and future projected trends in biodiversity will undermine many of the internationally agreed Aichi biodiversity targets. They will undermine the Sustainable Development Goals, all 17 of them, and it will undermine the Paris Agreement on climate change. And in particular, it will threaten poverty, hunger, human health, water, cities, and life on land. With that, Mr. Chairman, I'd like to close my remarks. Madam Chairman, apologies.
Thank you very much. Now we'll have Dr. Brauman.
Madam Chair, Ranking Member Lucas, members of the committee, thank you for the opportunity to testify today. This testimony is based on the global assessment of the Intergovernmental Science Policy Platform on Biodiversity and Ecosystem Services. As a coordinating lead author, I worked with a team of experts synthesizing existing, published research on nature and its very broad range of contributions to people. It is a big report. In short, people depend on nature. The deterioration of nature, species extinction, threatens the benefits that nature provides, from our basic food supply to our very sense of selves. And most of these benefits, these ecosystem services, are not fully replaceable. Some of them are irreplaceable. What do I mean by ecosystem services? Many of the material goods on which we depend, including food, bioenergy, medicines, other materials, come directly from nature. In addition, nature underlies the production of those tangible goods, and indeed, our very life support systems on Earth. Nature plays a critical role in cycling water, affecting climate, and protecting us from natural hazards. Nature offers more than this, however. Also critical to human well-being are the intangible benefits that it provides. Nature inspires science, technology, and art. It affects our mental health, and it provides a sense of place. Here in Washington, each spring the cherry blossoms bring joy and a sense of international connection, not to mention tourist dollars. In Minnesota, where I've made my home, our 10,000 lakes and our pride in the boundary waters are part of our collective identity. Yet the global assessment establishes that nature is in decline, so most of those benefits are declining as well. There are 5 main causes: changes in land and sea use, overutilization of plants and animals, climate change, pollution, and invasive species. Land use change has been the most important to date, largely because of its scale. Over the past 50 years, raw timber harvest has increased by 45%, and the value of agricultural crop production has increased nearly 3-fold. Let there be no mistake. Our transformation of nature has been critical for both human nutrition and livelihoods. But we also must be clear-eyed about the impact. We have transformed the globe. Today, over 1/3 of the terrestrial land surface is used for cropping or livestock. Agriculture, alongside growing urban areas and expanding infrastructure, has transformed forests, wetlands, and grasslands around the world. This has led to declines in many ecosystem services, particularly those that underpin the environmental processes and those that provide intangible benefits. For example, when we drain farm fields, soils and plants can no longer hold water, and this can exacerbate flooding downstream. Some of this we've seen in the Midwest over the past several months. Excess fertilizer causes toxic algal blooms, like the one that shut down Toledo's water system in 2014 and causes dead zones in the Gulf of Mexico. These impacts are widespread and pervasive. In the global assessment, we evaluated 18 categories of nature's benefits. Globally, we find increases only in production of material goods, goods whose value we already recognize. The majority of nature's benefits are in decline, including processes affecting air, water, and climate, as well as non-tangible benefits, such as the diversity of life from which to learn. Overall, the expansion of food, feed, fiber, bioenergy has occurred at the cost of many of these other benefits, and those burdens and benefits are often distributed unequally across space and time and among different segments of society. Agriculture is an example not just as a driver of environmental change, it's also threatened by these, particularly in the face of a changing planet. Healthy soils are the basis of everything we grow, yet land degradation has reduced productivity on 23% of global terrestrial area. Bees are critically important to more than 75% of global food crop types, including fruit, vegetables, and many cash crops. Yet they are also in decline, putting at risk as much as $577 billion in annual global crop output. This signals a threat to our continued ability to grow food and maintain productive agricultural systems. In addition, extinction threatens both wild and domesticated food plants and animals, posing a serious risk to global food security. Wild food relatives represent critical reservoirs of genes and traits that may provide resilience against future climate change, pests, and pathogens. Yet by 2016, of domesticated breeds of mammals used for food and agriculture, close to 10% are already extinct. Without soils, plants can be grown hydroponically. Coastal flooding can be managed by dikes and seawalls, but substitutes are frequently expensive and they incur high future costs. They cannot be the entirety of our Plan B. Looking forward, we can promote solutions by working with nature, and those solutions exist. Continued research is necessary, but there is much that we can do today. Thank you.
Dr. Porter.
If we could have the first slide, please. Thank you very much, Madam Chairwoman Johnson, Ranking Member Lucas, and members of the committee for inviting me here. I'll make my introductory comments with a clip of film from Chasing Coral going in the background. Coral reefs cover only 1% of the Earth's surface, and yet within that 1% are 25% of all marine plant and animal species. Coral reefs generate $9.9 trillion per year in economic benefit for 500 million people that depend on them exclusively for their source of income and for their protein. In addition to that, coral reefs generate $24 billion a year to Florida and Hawaii alone. And across coral reefs have generated amazing new drugs from the sea. A new drug from last year that reduces the risk of heart attack in elderly Americans, another drug that cures prostate cancer, and a third drug that is more powerful in killing the HIV virus than AZT. It is an amazing cornucopia. All of the ills that have been mentioned for other ecosystems apply to coral reefs, including exploitation and also pollution of plastics and invasive species such as a lionfish, which was from the Indo-Pacific, is now in the Caribbean. But the key driver of diversity loss in the oceans is, in fact, climate change. The reason for this is that corals are only 2 degrees away from the high temperatures that kill them. The irony is that of the warming heat that has been generated in the last 50 years, only 7% of that is in the air. The remaining 93% of the heat is in the oceans. The oceans have absorbed this heat. We know this because we have indeed measured it. If the oceans had not been the Earth's punching bag to take this heat, then the average temperature outside this room today would be 122 degrees Fahrenheit. That is the physics of what we are dealing with. I'm going to show you 2 examples from coral reefs. First from Jamaica. This is a picture from 1976. This is what this reef looks like today. You have a right to ask, is that from the same place? I direct your attention to the boulder coral with the distinctive eye spot in the lower right-hand corner. There it was before, here it is again. We are in the same place. Now let us look closer to home, the Florida Keys. In 1994, a coral reef off Key West. There it was before, and in 2004, the corals are gone. It does not matter what place in the Florida Keys you go to, you get the same result. 75% of all reefs in the Florida Keys have fewer species now than they did before. In the upper right-hand coral, some coral species have gone extinct, and the branching and elkhorn corals that you see in the lower right, once the commonest corals in the Caribbean, are now on the critically endangered species list. This committee deals with species, but on reefs, it's not just at the species level. The genus, the family, the order, the class, all are at risk. A recent paper in Science shows that 85% of the time that these higher taxa appeared on this planet, they did so on coral reefs, making them evolution's cradle and also their museum, the cradle to evolve new forms, the museum to retain them. An example is from the class sponges. They have the miracle that they can secrete their skeleton either out of calcium like you and me or out of silicon glass. The last time a class of organisms on this planet went extinct was 500 million years ago. And within the next 50 years, we can eliminate this class. We are not only trimming the leaves, the species, we are trimming the branches, the trunk, and the roots of the life on this planet. Climate change is the cause, and we are worried that in 2040, we are going to see a loss of coral reefs worldwide as they bleach and turn white and die. But if we were able to reduce the amount of greenhouse gases through all the kinds of technologies that imaginable, we could take that 2040 away and buy coral reefs at least 100 years in which they might be able to evolve thermal tolerance. 75% of the living coral in Florida has died in the last 10 years. 66% of all corals on the barrier reef died in the last 2 years from climate change. This committee is about life on Earth. We can save the biodiversity of the planet, but we must begin now. Thank you for coming.
Thank you very much, Dr. Goodwin.
Chairwoman Johnson, Ranking Member Lewis, members of the committee, thank you for this opportunity to provide testimony on behalf of Noble Research Institute. The recently published global assessment of the Intergovernmental Panel for Biodiversity and Ecosystem Services discusses in depth the estimated projections and global biodiversity loss and the perceived negative impacts imposed by the agricultural industry. To the contrary, for more than a decade, a movement has been taking place in the ag industry that is returning biodiversity to the land. A significant number of farmers and ranchers, producers across the country and around the world are part of an agricultural revolution, a regenerative revolution, focused specifically on biological diversity and building biologically active soils. This movement, however, was not born out of legislation or regulatory requirement. It was born out of the recognition by innovative producers who understood the adoption of ecologically and economically sustainable principles would enable them to remain on the land, producing the food and fiber needed for an ever-expanding population. 60 years ago, the agriculture industry operated on cheap fuel and fertilizer. Our industry and our research during that time focused on the chemical and physical characteristics of soil with little to no consideration of the biological interactions. In recent years, prices for food and fertilizer have increased to the point that have become unsustainable for many operations. Many producers have had to make a choice: continue what they've always done or work with nature to find a new solution. Born out of equal parts necessity and frustration, producers began to experiment with farming techniques that limited the use of inorganic fertilizer. They began to see that limiting or eliminating tillage reduced their fuel bill, and using the ageless practice of cover crops to keep their fields covered provided numerous benefits to the soil, like preventing erosion, like increasing the soil's water holding capacity, and yes, increasing biodiversity. In essence, they built a foundation of principles that producers follow today to manage healthy soils. These soil health management principles were set forth to achieve specific goals inherent to all soils. They mimic highly diverse, heterogeneous native rangelands by harnessing the power of biologic interactions between plants and soil microbes. These principles build soil aggregation, which further builds soil structure, which increases water infiltration and ultimately increases the soil's resilience. These principles provide innovative producers a path forward and substantiate that the conventional farming practices of the last 60 years are not the only way. These principles were developed by producers for producers. Principles like armoring the soil, keeping the soil covered. Soil cannot be built if it's moving. Optimizing or minimizing disturbances. Increasing species diversity, keeping living roots in the ground as long as possible, and properly integrating livestock. In 1949, Aldo Leopold, considered by many to be the father of conservation theory and wildlife management, taught that land stewardship was not only rooted in conservation, but also involved an ethic of stewardship. He wrote that the individual is a member of a community of interdependent parts. The land ethic simply enlarges the boundaries of the community to include soil, water, plants, animals, or collectively the land. Simply put, once we understand that humans are not separate from, but are part of and depend on the natural community, we develop an ethic to care for the community as a whole. For years, those who oversee the use and protection of our soil, the producers, have been disparaged and in many cases demonized for the practices in which they engage. However, the reality is that those entrusted with the mantle of land steward embrace the same ethic taught by Mr. Leopold. Producers today are implementing principles that return biodiversity to the land. This stewardship cannot happen without those stewards on the land. Thank you.
Very much. Dr. Montfort.
Thank you, Chairwoman Johnson, Ranking Member Lucas, and distinguished members of the committee. My name is Steve Montford, and I'm the director of the Smithsonian's National Zoo and Conservation Biology Institute. In addition to representing my zoo colleagues, I'm honored today to represent my Smithsonian partners from the Environmental Research Center, our Tropical Research Institute, and the National Museum of Natural History, and others united under Smithsonian's umbrella called the Conservation Commons, which is an institution-wide effort designed to foster collaboration in tackling complex conservation problems. At the National Zoo, you probably know that we care for and conserve some of the rarest species on Earth. But what may be less known to you is that the Smithsonian has been studying biodiversity for 170 years plus. Today, hundreds of Smithsonian scientists and scholars work across the spectrum of biodiversity and conservation science, from genomes to individuals and populations, to forests, watersheds, and fisheries, to understanding the impacts of infrastructure development, pandemic diseases, and human-animal conflict. Work that is focused on understanding and sustaining a biodiverse planet, which we've been hearing is the very fabric of what we define as nature and all of its vital contributions to people and all life on Earth. As evidenced by our incredible new fossil haul, which I'm sure you'll all have a chance to see soon, our collections represent the best planetary record that humanity possesses. They document long-term baselines, trends, and changes about the planet, biodiversity, and even human cultures. And what we've learned is this: it took 200,000 years for the human population to reach 1 billion people, but only 200 to reach nearly 8 billion. And this has resulted in profound planetary change. The IPBES report essentially confirms what we have long known. Humans have made things very tough for nature. And yet, as you've also heard, we're inextricably linked to and connected and dependent upon biodiversity, upon nature. Because quite literally and very simply, every breath that you take, every drop of water that you drink, every bite of food that you consume is in one way dependent upon biodiversity and functioning ecosystems. Over the next decade, we know that trillions of dollars are going to be invested in things like infrastructure development and land conversion to support the livelihoods of a growing human population. But without better planning, proper planning, this development will continue to be a major driver of animal mortalities, of habitat fragmentation, species invasions, and the spread of pathogens that are responsible for global pandemic disease threats. The ongoing and real threats to biodiversity are clearly daunting, and yet if we just bombard the public with messages of gloom and doom, absent any focus on solutions, we risk fostering a sense of that nothing anyone does is going to make a difference. So to counter this, in 2017, the Smithsonian launched Earth Optimism, which is a worldwide forum for sharing and curating stories of conservation success. Our next summit aims to reach 1 billion people around the world on the 50th anniversary of Earth Day, which will be in April of 2020. And of course, you're all invited to join us. In my own experience, increasing collaboration increases the chance of finding solutions. And I'd like to share 2 examples that I believe demonstrate that. The scimitar horned oryx is a large, magnificent desert-adapted antelope that once roamed widely across the entire Sahelian grasslands of North Africa, from Senegal to North Africa, like American bison, widely distributed. The species was declared extinct in the wild in the 1980s as a result of war and overhunting. And fortunately, though, large populations of this species were maintained in human care, both in zoos and private collections worldwide, including at the Smithsonian. In 2010, the Smithsonian helped to convene a global network of stakeholders that included the governments of Abu Dhabi, which managed large populations of oryx in their own herds, and the government of Chad, which sought to restore the species to their historic rangelands. And so it was through this diverse partnership that in 2016, I had the amazing opportunity to personally witness the first group of oryx to touch Chadian soil in more than 30 years. Reintroducing oryx back to Chad is really just the first step in restoring ecological balance in an entire Sahelian grasslands ecosystem upon which people depend for their livelihoods. Another great example comes from our Tropical Research Institute in Panama. As you know, the Panama Canal is a massive lifeline of global commerce, but large ships were routinely colliding with humpback whales, which was, of course, catastrophic for the animals, but also had the potential for disrupting global trade. Our scientists used GPS tracking devices to monitor the movements of these whales And through collaboration with the Panama Canal Authority, these data were used to reestablish new shipping lanes, which resulted in a 93% reduction in ship whale collisions. So win-win solutions for people and nature will require us to adopt new standards of practice that recognize that integrating conservation and science across multiple sectors into development practice is good for our economies, it's good for our families, and good for every global citizen, because we all have a stake and will benefit from sustaining a biodiverse planet. Nature must have a place at the decision-making table, not as an interloper, but as an existential partner if it is to fulfill its role in providing its incredible benefits to current and future human societies. Thank you.
Thank you very much. Let me thank all of our witnesses. And before we begin our questioning, I'd like to present 5 documents for the record: letters from the Center for Biological Diversity and the International Fund for Animal Welfare, and statements from Dr. Jacob Malcolm at Defenders of Wildlife, Dr. Bruce Stein at the National Wildlife Federation, and the National Resources Defense Council. All 5 documents highlight the shocking and frightening findings of the IPBES report. Further, the letters and statements call for aggressive science-based action to address this crisis. And so without objection, I'm placing these 5 documents in the record. At this point, we will begin our first round of questions, and I recognize myself for 5 minutes. Dr. Porter, we appreciate you being here today to talk about the corals as a case study in biodiversity. Your participation is especially timely since the World Reef Awareness Day was just this past Saturday. You mentioned in your testimony that corals are a marine medicine cabinet of sorts, that the unique organisms we find only in coral ecosystems are being used for new drugs that address deadly diseases. Can you talk a little bit more about the health innovations that have resulted from corals so far?
Yes, thank you, Madam Chairwoman. I can be quite specific about this. A new drug has just been discovered from tropical sea fans called prostaglandin. It's one of the most effective at curing breast cancer. And another drug has just been discovered from a strange marine creature called a bryozoan, and that one has been used to cure prostate cancer. Coral reefs are the oldest environment on Earth, with 400 million years of continuous evolution. And at that point in time, with that kind of time, they have evolved chemicals to defend their own territories and their own lives. And we humans are benefiting from 400 million years of their evolution. Thank you.
Well, thank you. Are these research activities supported by any federal grant funding?
Absolutely. All of the federal agencies that have marine aspects to them are involved. The National Science Foundation, the Environmental Protection Agency, National Oceanic and Atmospheric Administration also has sanctuaries program, and in addition, funds coming from the Smithsonian have been key. I myself was a pre-doctoral fellow 50 years ago from the Smithsonian, thank you, and that started my career. They are education and research involved in all of those agencies. Their ocean missions must be supported.
Well, thank you. Now, the pharmaceutical innovators that are already experiencing challenges when they seek to develop new therapies due to the coral bleaching and deaths, could you expand some on that?
Yes. Corals are a mixture of a plant and an animal. 15% of the weight of a coral is actually living algae. And this symbiosis is the basis of coral survival. When temperatures rise, the algae are no longer able to photosynthesize, and they leave the coral and it starves. That's why temperature is so disastrous. We are involved in genetic research and biochemical research to understand that intimate linkage. We know that some corals over the last 50 years have developed a tolerance for higher temperatures. This is by the production of heat shock proteins. Those heat shock proteins may indeed help humans survive elevated temperatures. There's active research from all of those agencies on the resistance of corals to rising temperatures, but the scale of the problem, the whole world's oceans are involved, means that we should cut the problem off at its source as soon as we can. Thank you.
Thank you. Now, Dr. Watson and Dr. Bowman, your report says that biodiversity supports social and mental well-being in people, and that biodiversity loss is already having negative effects on our emotional health. Can you comment some on that, both of you?
Yes, thank you. There's no question that people have mental well-being when they walk through a forest, when they walk by a river. We also found in a separate study that I chaired in the United Kingdom that if you looked at the price of housing that was close to a park, close to a river, close to a forest or woodlands, the price of houses went up quite considerably, basically. So there's lots of evidence that people feel good when they commune with nature, basically. And as we destroy our forests, we destroy our rivers, basically people lose out. And so mental well-being is indeed a crucial aspect of one of the benefits we all get from nature.
I'll add that there's really excellent growing research on child development and exposure to nature, that the complexities and interesting parts of being in nature as a child are very important. The field of studying actually biophysical mental health response to nature exposure is growing and is certainly an area that's very exciting and in need of further research.
Thank you very much. My term has expired. Mr. Lucas.
Thank you, Madam Chairman. Mr. Goodwin, one of the soil health management principles you mentioned is optimize disturbance. You and I both know, but many of our colleagues might not, that prescribed burns, grazing, herbicide applications are actually beneficial for land if managed correctly. You even point out in your testimony that the Great Plains has lost some of its vast biodiversity because of limiting or completely removing fires and grazing. I guess my question is this: when talking about land use, can you explain why actively managing land is more beneficial to the environment and biodiversity than simply letting nature run its course?
Yes, sir, and thank you for the question. I think it's important. For us to understand the history behind how these ecosystems evolved. When we look at the Great Plains, or Southern Great Plains in particular, those systems evolved for thousands of years. The plants, the soils, the animals, all of them evolved under two primary natural disturbances: grazing, herbivory, and fire. Today, our producers manage those two disturbances with prescription. They manage the timing, the intensity, the frequency, the duration of that grazing event and that prescribed fire to benefit habitat management for a number of species. For instance, the timing of a prescribed fire might increase forage production for both game and non-game grassland bird species. And so understanding really the history behind it, plus also understanding that we need to educate policymakers and the growing public on the benefits of both grazing and fire in these systems. We used to have a fire culture in this country. We used to teach it in grade school. We don't do that anymore. I think we need to understand that if we understand those two items, then we've moved a long way into the future to helping biodiversity within that system.
And Mr. Goodwin, when talking about modern agricultural practices, you refer to this movement as being born out of innovation and economically stable practices. You say specifically that this is not born in a laboratory or formed by regulatory requirements. There's a fine line between doing things for people and doing things to people. Congress struggles to walk that line sometimes. Why is it important that these practices you discussed in your testimony be driven by producers and left unimpeded by regulation?
I think just like the diversity that this report is trying to protect, the agricultural landscape is just as diverse. We look across the U.S., we've got extremely diverse soils. We've got different climatic zones. We've got different production systems with different production capabilities. We even apply our practices differently depending on the location. And so, in short, when we look at farms and ranches, no two are equal. Different soils, different plants, different associations. So these regenerative solutions that were built by principles, they were built on that producer's innate ability to be innovative and doing things differently on their own without being asked or forced to. So as we look at policies that establish sort of blanket or one-size-fits-all regulation, we would largely end up with unintended consequences and ultimately limit our producers' freedom to operate and freedom to innovate.
Mr. Goodwin, neither you or I are old enough to have been in Oklahoma in the 1930s, in the Great Dust Bowl period. But in your testimony, you say producers began to experiment with farming techniques based on equal parts necessity and frustration. Can you elaborate on those frustrations, the lessons discussed, how we move forward, and compare where we are now on farms and ranches with where our ancestors would have been in the gut of the 1930s, the horrible part of the Dust Bowl in that period?
Certainly, the Dust Bowl was a terrible time. Families were decimated. So was the land. It was the formation of many organizations, mine included, as well as the Soil Conservation Service, as you well know. I think some of the frustrations we face is we need to keep in mind that farmers and ranchers, it's not Hollywood, it's a business. Some are large businesses, some are small businesses. And input costs over the last 60 years have increased to where those producers can't operate the way they've once were. They're business owners, and they need to have that ability to look for compelling ways to stay innovative. Those are some of the ways that have led to those frustrations, and really to abandon. They've moved them towards abandoning tradition of the last 60 years and looking for those compelling regenerative solutions that help them ecologically and economically, sustainably provide that food source for the growing public.
So essentially, whether it was for the right reason or the wrong reason, nonetheless, producers out there have been compelled to adopt a better path.
Most certainly.
Thank you. Yield back, Madam Chair.
Thank you very much. Mr. Barrow.
Thank you, Madam Chairwoman. Dr. Montfort, you talked a little bit about the impact of population, and I don't remember the exact numbers you gave, but clearly our population is rising at a much faster rate than when we looked at history. My other committee is the Foreign Affairs Committee, and we spent a lot of time thinking about the impact in sub-Saharan Africa, kind of this youth bulge and, the number of people that are displaced right now, not just by war, but by famine, by lack of water, et cetera. And, if you could just maybe expand a little bit on, we all understand the impact of climate change on loss of biodiversity, et cetera. But if you could maybe comment on the impact of, population expansion.
Well, generally, population expansion means an increased use of resources or a wiser use of resources. Sort of referencing the question earlier, it had to do with, whether we have protected areas or national parks set aside and allow them to remain intact versus what goes on outside the park. And the truth is we live in functionally what you would describe as a landscape mosaic now, where virtually the entire globe is a variety of different land usages. And so we're really in a situation where we need to wisely be able to manage those resources. If you go back to the example of the oryx, these are nomadic peoples that are using a grassland, a rangeland system, grazing camels and other livestock. And reintroducing oryx is really an effort to introduce land management practices that will allow sustainable use of these ephemeral grasses that will support livelihoods of the people there. So oftentimes it is absolutely about better management, better land stewardship, and creating win-wins with the people who depend on biodiversity for their survival.
So as a life scientist, I'm a physician by training. I agree with everything that you're saying. Now, I'm going to do a town hall on Thursday evening, and I'm going to have to explain to my constituents why this is incredibly important. So if each of you could give me a way to put into words that, you know, that mom or dad who's trying to pay their mortgage, that's trying to get their kids to soccer practice, would take the urgency of, you know, why this is an impact, maybe starting with Dr. Watson, how I would explain it in a sentence or two to my constituents.
To answer your first question, sir, is a combination of an increasing population and a wealthier population has led to an increase in per capita consumption. And so we need to deal with both of those issues. But biodiversity fundamentally is not just an environmental issue. Nature has economic value, which we should take account of in our accounting systems. It also has development value, food, water, energy security, human health. It also is a moral issue. We shouldn't destroy nature. And there's a social issue, as you've heard, that the most disadvantaged of people, poor people, are most adversely affected. So there's multiple reasons we should care about both climate change and biodiversity.
Right. Dr. Brauman.
From the very food we eat to the way we define ourselves and our sense of place, nature is an incredibly integral part of all of our lives. And when we destroy nature, we really undermine all of those life support systems on which we depend.
Great. Dr. Porter.
Yes. 94 countries, half of all nations on Earth, have coral reefs within their boundaries. If we destroy their source of income and protein and livelihood, they will be the climate refugees that will move all over the world and make this place more conflictual.
Great. Mr. Goodwin.
Yeah, I mean, I think it's just important to recognize that nature is important, and we need to do a better job of telling the story of the good things that are happening out on the landscape as well.
Great. Dr. Montfort.
Yeah, some of these have been said, but ultimately it's about health and prosperity and security are sort of fundamental policy issues. But if anyone enjoys being in nature, hiking, camping, fishing, hunting, any sort of recreation, they should care about biodiversity.
Great, thank you. And I'll yield back.
Thank you very much. Mr. Babin. Mr. Biggs. Oh. Mr. Moore.
Okay, thank you so much. I'm one of those people that enjoy being out in nature, and I've always believed that the solutions that rely on sound conservation practices and innovation. I'm a big fan of Ducks Unlimited, Pheasants Forever, Quail Unlimited, the National Wild Turkey Federation, just to name a few that I've been involved with. And the key to all these programs are reestablishing habitat, that we as hunter and fishermen know that habitat is absolutely the key to success. And great stories I could share of what particular Ducks Unlimited has done to reestablish some of the wetlands areas through North America. Mr. Goodwin, you have any relationship with any of those organizations? I'm kind of shooting from the hip here.
Well, I mean, I'm certainly a hunter and a fisherman, enjoy the outdoors. I'm on the board of directors for the Society for Range Management that promotes habitat management across all of rangelands. So would you like me to address a question?
Not yet. I'll give you a follow-up question here. One of the big investigations I went on several years ago was trying to understand the lesser prairie chicken, what's kind of happened to its population and something that might impact part of their rangeland is down in Oklahoma as well. And what I discovered is the best place in the country at reestablishing that habitat actually went back to the way nature was hundreds of years ago, in that we had buffalo ranging through the Great Plains. They didn't stay in one field. They ranged up and down north to south in the season. So there was grazing practices, and guess what? There was also natural occurring fires. And the people that are replicating those, establishing that habitat, and a little bit of rain is what's really brought back the prairie chicken population. So maybe just give you a little bit more rope to talk about how important it is, using maybe tie in some weather reports, national weather reports, how we use those to prescribe fire practices, and how we're using that for even endangered species like the lesser prairie chicken.
Thank you, sir. Yeah, and so when we look at how we manage landscapes from a rangeland perspective, habitat is always in our mind. I mean, this is habitat for numerous terrestrial species, and so when we look at those management practices that we apply to that landscape, certainly fire and grazing are important to those, and they're not necessarily just practices; they're ecological processes that helped meld and help those processes and that ecology evolved. Specifically with the lesser prairie chicken, yes, they like those heterogeneous landscapes, so that they can have their leks and their booming grounds, and managing that the timing, frequency, intensity, and duration of grazing and fires, how we help that species evolve and sustain itself. And so certainly, with respect to NOAA and prescribed fire, yes, most certainly we use those data every day. When we employ or implement a prescribed fire, it's by prescription. We prescribe the weather conditions, we prescribe all of the conditions of which we burn, and we ask for a site-specific spot weather forecast. Those data are absolutely invaluable to us, not only from a perspective of planning, but also safety. It helps us document the pre- and post-burn conditions, and most importantly, it helps us make management decisions on the ground.
Exactly. I've done quite a bit of that pasture burning myself. I've often suggested I should sell tickets to let people help me, but that wind report is especially important. Dr. Porter, you were referring to some biopharmaceuticals and their use of coral. One of the great things about people in the hunting and fishing realm is that we always work just as hard to leave it better than we found it, and want to go back and work with the habitat to help it be better. What's happening in the world with big pharma, whoever's accessing some of these coral medicines? What are they doing to help refurbish the reefs?
Yes, they have been very active in that. For coral reefs, there is an entire program called bioprospecting, in which animals from coral reefs are being investigated. It turns out the sponges are especially good at giving us new compounds. They have been an ally. I have also worked with Trouts Unlimited exactly for the same reason. They are a force in conservation, and they should be supported. Thank you.
Thank you so much. I yield back.
Thank you so much. Mr. Lamb.
Thank you, Madam Chairwoman. Mr. Goodwin, wanted to ask you about some of your research into cover crops and where you've seen success out where you are. The climate of where I come from in western Pennsylvania is probably pretty different from where you're conducting research. We're seeing an increase in particularly early season storms, rainstorms, very intense, so dealing with a lot of water. Are there crops you've seen in your research that have been especially effective at increasing the biodiversity of the soil when it comes to kind of a wetter environment?
Well, Oklahoma and southern Great Plains aren't necessarily known to be a wet environment, although I'd argue this year it's pretty wet. Mm-hmm. So I think when we step back and we look at how we design cover crop mixes, we certainly test the soil. We want to understand what condition that soil is in, and then we tailor cover crop mixes to help us balance carbon and nitrogen ratios to increase not only the species diversity, but in above ground biomass, but also rooting structures.
Right.
We don't want just tap rooted perennials. We want fibrous root systems and all those, and those all help us increase soil structure. It helps us to increase infiltration. We don't have any control over how much rain we get, but we certainly have control over how much we keep and how much infiltrates into the soil and recharges aquifers.
So are there certain species that help with that, with the more deeply rooted systems that you're looking for? Or?
Yeah, I mean, we've got forb species like forage collards and nitro radishes and those sort of species that wildlife do use. They provide flowers for pollinators, and they also have deep tap roots that help leave or help that integration to where we can get infiltration further into the soil profile.
And I'm aware that there is some research going on more widely about whether we can develop new forms of cover crops that will more efficiently store carbon and sequester carbon at a higher rate than some of the existing ones. Is your organization involved in any of that research, or are you familiar with it? Are you seeing any success in that area?
We are. Noble Research Institute's keenly involved and interested in understanding how we can use cover crops in specific areas. They're a tool. It's not a silver bullet. Certainly when we look back and look at how we want to manage for soil health, they're one piece of the pie. Just because I plant cover crops doesn't mean I'm increasing my soil health. I have to manage that crop specifically. But yes, we're most certainly interested in understanding, again, how that root dynamic adds to carbon sequestration. How do we increase the root's ability to increase the productivity of that plant, but also how does it attract the diversity of microbes? We learn more and more that more of the organic carbon in the soil is actually microbial bodies as well as decomposed organic material. So, yes, sir.
Thank you. And Dr. Brauman, I saw you nodding your head, so if you want to jump in. I'm just curious about specific research efforts that maybe we could look at to try to help further along that maybe involve new species of cover crops or rediscovered species. Are you familiar with that at all?
Absolutely. There's really interesting research going on at the University of Minnesota, and I would be happy to submit some information about that for the record. One of the things that they've been working on are actually perennial cover crops and perennial food crops. So these are in development, but what we're starting to see are crops that are sort of on the verge of coming to market, like perennial wheatgrasses. What that means is that there's not actually a bare period on the soil at all, and especially with these wet springs, which in the climate forecast, we see much wetter springs in the middle part of the country, as well as drier falls. And so having those crops on the ground is really important. Nice research at the University of Minnesota. We're seeing really nice cold weather research, which is relevant to Western Pennsylvania as well as Minnesota, where what we want to make sure is that we don't see, for example, fall applications of fertilizer. Instead, the fertilizer goes on after crops are in the ground and in multiple iterations, so that when we have wet springs like this, it doesn't all just roll right off the ground.
I see. I read something about a variety of mustard plant that people were trying to create out in California. Are you familiar with that, Mr. Goodwin? Have you?
Not
It was a new, I think it was a genetically engineered new plant that they thought would add carbon at a higher rate. Just a last technical question. If we ever got to the point where, say, we decided we wanted to try to compensate farmers for growing a certain type of cover crop because it increased, it took carbon out of the atmosphere, is that a technically possible thing to measure? Like, can you measure how much a farmer has contributed with the crop they use? Go ahead, Dr. Brauman.
Absolutely, and there's research going on at the University of Minnesota on exactly this issue right now, and it's going to be critical. I'm not sure what the situation is for rangeland in Oklahoma, but in Minnesota, sowing cover crops is expensive, and lots of farmers can't afford to do it unless there's a way to monetize that somehow. It's just an extra cost on their shoulders when it's a benefit to all of us to do it. And so looking for incentives and payments is going to be critical.
Great. Thank you. I yield back.
Thank you very much, Mr. Beard.
Thank you, Madam Chair. Dr. Goodwin, I know, and you mentioned that the importance of the land to farmers. And, the scientists at the Colleges of Agriculture and Agriculture Extension programs are constantly developing innovations and looking for better ways to produce more food on less land and water. So one of the things that I see is the new technology and the equipment that we have today, we're able to more specifically place some of the things that are important to growing a crop. And the universities and the agribusiness as well as the extension program are constantly looking for ways to improve on that. So I guess my question is, would you care to comment on how important that aspect of this research and protecting biodiversity?
I think there's always room for technology. We can, anytime that any of us say that we don't have room for improvement, it's a foolish statement. And so And so certainly, we always look for technological solutions if there are. I think in this case that there's certainly room for technological solutions like new sensor technologies to help us understand the ecological dynamics that we can't see. I also think that we need to step back at times and say technology is not always the solution, that we need to work with Mother Nature and help understand that we can apply these ecologically beneficial practices and still feed the planet.
So thank you. Dr. Brauman, you discussed the importance of biodiversity in agriculture. Are there any other crops besides soybeans, for example, like the work that's being done at Purdue on internationally renowned for the work in genetic structures of crop plants like soybeans? So are there any other crops besides soybeans that are lacking in biodiversity and in the need of innovative research?
I can't speak to the specific crops where there's great potential, but what I do know is that there are many crops where this kind of development could be incredibly beneficial. Soybeans had a huge development in the mid-century of last century to get them to the productivity point that they're at today, and they're continuing to do that work. We know that with almost all of the crops we grow, anytime we can do innovation, and that ranges from reducing drought sensitivity to better utilizing nutrients, to simply being better cited in the places where we're growing them, that we are able to grow food more efficiently with less inputs, and that's always a benefit.
Thank you. Back to you, Dr. Goodwin, or Mr. Goodwin. You noted that the Nobel Research Institute conducts independent agricultural research similar to our land-grant universities. So how does the NRI disseminate its research to the broader agricultural industry?
We provide consultation services directly to farmers and ranchers in the Southern Great Plains. So we work directly with those producers in an interdisciplinary approach to provide conservation recommendations based on their goals and objectives. And we also have an extensive educational program. We have thousands of people a year come to the Institute to learn by seeing what exactly we're doing and how we implement those practices on the 15,000 acres that we own and operate as an institute. We also certainly publish in popular and scientific journals. Thank you.
One last quick question. Do you feel this works well for small farmers as well as large agribusiness and so on?
I think there's a regenerative solution for all size operations. I don't think size has is a limiting factor. The limiting factor is, do we think we can do it? And the answer is yes.
Thank you, and I yield back.
Thank you very much. Ms. Stevens.
Thank you, Madam Chair, and thank you to our expert witnesses for joining for today's panel, and congratulations on the recent report. Certainly quite timely for us as the Committee on Science convenes to make its mark on how we can protect our biodiversity. We recently had a hearing in the Subcommittee for Research and Tech on plastics and recycling technologies. I continue to hear from municipalities in my district, suburban Michigan, around the challenges that they're having on recycling due to the lack of infrastructure. And Dr. Brauman, you in your testimony referenced plastics pollution. That it's increased tenfold since the 1980s. And I'd like you to just talk a little bit about the urgency that we have in the country to invest in infrastructure to handle the waste that we produce with plastics, and maybe talk a little bit too about the time frame that we have in making these investments to revive some of our biodiversity in this country.
Thank you. There are there's been a huge increase in plastics and indeed in all kinds of waste, from food waste to waste that does not biodegrade, like plastics, in the United States and around the world. We see this increase in consumption very clearly in the report. And what that's done is create waste that we then have to do something with. And the need to be able to recycle and reuse these waste products, as well as to simply produce less of them, is critical. We know that particularly in the oceans, there's a huge problem with plastic waste, and that there's little that we're able to do about it once it's in the oceans. And so stopping it before it gets there is something that is incredibly important.
In the oceans and in our food.
Yes. Microplastics is actually a fairly good example of things that people have begun to take out of products, at least in the United States. And so it's clear that we can do something about this when we want to. We are, however, seeing lots of these things everywhere all around the world. And so making sure that we can reduce consumption, reduce waste, and then also manage waste in better ways is critical. And the sooner we do it, the less we're going to have to clean up later.
Yeah, great. Thank you. Yeah, did you want to chime in, Dr. Porter?
Yes, thank you.
Yeah, please.
The estimate now is that by 2050, there will be more plastic in the ocean than fish.
Yeah. Great data point. Thank you. We're not doing it right in the hearing on biodiversity loss and causes if we're not talking about invasive species. I'm also not doing my duty as a Michigander without talking about Asian carp that has created huge problems in the marine ecosystems in the Mississippi River and in Illinois. There's been a long campaign to build the infrastructure to keep Asian carp out of Lake Michigan. Currently, there is a $778 million plan to stop the spread of Asian carp to the Great Lakes. The leading edge of the carp population is really, at this point, only 47 miles from Lake Michigan. And Dr. Watson, if I could turn to you on this, in your testimony, you referenced that invasive species such as Asian carp will likely exacerbate some of these trends that are continuing to negatively impact biodiversity. Where do you believe the federal government could rightly partner at the state and local level in investing to make the biggest impact in combating invasive species?
Yes, as our report says, alien invasive species are one of the 5 direct drivers of loss of biodiversity. And indeed, especially in freshwater systems, such as you've mentioned, one has to take care. The real challenge is to prevent alien invasive species entering our system in the first place. Once you get these species, it's very hard in many cases to get rid of them, basically. So I'm not sure what, to be honest, our report didn't deal at the subnational level with approaches to dealing with the alien invasive species, although Kate may have some better ideas.
I will say that in Minnesota, we've actually, the uppermost lock and dam on the Mississippi River is now permanently closed. And so that was obviously work that was done with the Army Corps of Engineers, in large part to make sure that invasive carp don't actually get above that part of the river. But I absolutely agree with Dr. Watson. We at least know the problems we're facing with the invasive species that are in the country already, and there's no reason to think that future invasive species won't be worse. And so doing a better job keeping those invasive species out is going to be critical.
No, it's like a bad horror movie with the carp. Dr. Montfort, I know you were raising your hand, and we actually wanted to get you in on this.
Okay, sure. I just
reference the Smithsonian and all sorts of great programs. So.
Well, the one thing, one of the ultimate invasive species has been the chytrid fungus, which is responsible for a global decline in amphibians. And so studying the origin of these invasions and tracking them and understanding how they function is something also that we need to do better a job with. At the Smithsonian, though, we work with the Coast Guard and on marine invasive species, and we have the National Ballast Information Clearinghouse System, which is a system that samples ballast water from all ships that are coming into our ports, and we've monitored 550 species of marine and estuarine invertebrates and algae, for example. So this is an example of how you can go about being proactive in monitoring and tracking these organisms and how they're moving.
Fabulous, thank you. I yield back the remainder of my time.
Thank you very much, Dr. Babin.
Yes, ma'am. Thank you, Madam Chair. Thank you, everyone, for being here. Appreciate your testimony. Dr. Brauman, I would like to ask you first. I have the honor of serving as the ranking member on the Space Subcommittee, as well as getting to represent Johnson Space Center. And I've seen many examples of NASA's collaborations with private partners to foster innovation and technological growth. And from remote sensing robotics to GPS and technologies for growing crops in space, NASA space exploration and science, Earth science efforts have yielded remarkable benefits for farms and economic activities and industries. Do you see more collaborative opportunities like these to address the issues that we're discussing today of biodiversity?
Absolutely. I have actually received a grant from NASA last year to run a series of workshops where we brought practitioners as well as researchers together to look at better ways to use Earth observations as we assess and do management based on ecosystem services. And it's clear that there's a tremendous opportunity. One of the things that's also very clear is that in addition to more basic research, we need to be supporting a lot of the background systems that make the kind of information that NASA is developing more accessible to more people. So if you're an expert, if this is what you do for a living, it's easy to grab their data and do informative things, but it's hard if you're not.
Great, thank you very much. And Mr. Goodwin, the threat of pollution on biodiversity and ecosystems is a global issue, and a solution is reliant on the participation of other countries as well as us. How can we ensure that other countries, big polluters like China and India, are taking the steps towards cleaner solutions, and that the financial burden of tackling global pollution isn't solely on the backs of the American taxpayer?
I'd have to say that's out of my wheelhouse. I could speak to the benefits and the good things that our producers here in the United States are doing, but I'm not your guy for China.
Okay. But you catch my drift, though, right? Well, I'll ask you another one. You mentioned in your testimony many different practices that have increased soil health and productivity. Similarly, to my second question, do you see any other countries adopting similar measures? Now, that may be out of your wheelhouse, too. And how can we make sure that these other countries are taking steps forward in these areas as well, and that the U.S. is not the only party making these strides?
Well, certainly for soil health management strategies, this revolution is not it's not solely performed in the United States. There are producers, ag producers all around the world implementing these principles. And if we focus on the key core soil health building principles, when we look at habitat and we look at diversity, often we look at it from the top down, and I would submit we need to look at it from the bottom up. We need to fix the foundation, increase the soil health, increase the plant communities. Those plant communities provide the habitat for those wildlife species. Those principles work whether you're in Nairobi, Kenya, or in Muskogee, Oklahoma.
Okay. Do you believe it should be the role of the American taxpayer through taxes and regulations to be responsible for solving these issues? And do you believe that through private partner relationships that we can foster innovation and efficiency?
I most certainly think there's opportunity for partnerships. I do think it's the role of each individual producer to have the ability and the freedom to operate their producer or their private property as they need to, and more producers are seeing that these ecologically focused principles are benefiting us in both ways, both economically and ecologically.
But is it the American taxpayer's job to solve the problems on the global issues?
No, sir.
Okay.
It is not.
All right. And then also, my last question, I represent Southeast Texas, which is home to a lot of ag, and it just so happens in my district is unfortunately also in a flood-prone region with hurricanes. This has created a lot of issues with harvesting and crop production. Can you elaborate a little bit on how some of these new practices could help protect crops and soil during inclement weather and floods?
Well, certainly, if we look at again those foundational principles, the first one is keeping the ground covered. We don't want those erosive losses providing further sediment downstream any more than anybody else does.
Right.
And so, yes, the principles help us build the ability and the capacity for those soils to hold water back. And so we're gonna fix these ecological problems with principles, not just applying practices on the landscape. We have to rethink how we look at it and focus our practices and look at our practices as a set of tools and implement those where they need to be locally.
Okay, thank you. My time's expired, Madam Chair. Thank you very much.
Thank you. Mr. Tonko.
Thank you, Madam Chairwoman. Dr. Watson and Dr. Brauman, I would like to pause to get a better picture of how the IPBES conclusions were reached and what the scientific process looks like in practice. Who wrote this report?
Thank you. First of all, governments around the world scoped the report. In other words, they worked with the science community to say what were the big scientific policy issues that needed to be addressed. We then had governments and the scientific community nominate experts to write the report. Within IPBES, we have a multidisciplinary expert panel and a bureau. I used to chair the bureau. We then selected scientists from around the world, 145 to be precise, who wrote the report. Another 300 scientists around the world helped these 145. Very strong peer review. We sent out our reports to experts and governments around the world twice, and we received 15,000 comments on our report. We responded to all 15,000 comments, and then effectively governments around the world accept the large report, the 1,700 pages, and then with the academic community, the lead authors and the co-chairs, we then negotiated the summary for policymakers, the 30-page document between governments, including the US government. Over 100 governments participated in Paris, and the lead experts such as Kate and the others. So it's a very open process, incredibly transparent. We publish the comments, we will publish all the responses, and it's probably one of the most heavily peer-reviewed documents you will ever find.
Okay, and Dr. Brauman, do you concur with?
Absolutely.
Okay, and were any of the authors paid by industry to represent a particular point of view in their participation in the report?
No, everybody that participates in IPBES, whether they come from academia, such as Kate, whether they come from a government or a government laboratory, or an NGO, or the private sector, it's absolutely essential they participate in their individual capacity. IPBES has a conflict of interest committee, and we scrutinize every single person that is either an author, a co-author, a review editor, to make sure there is no conflict of interest. I used to chair such the panel.
Okay, well, I thank you both. As someone who deeply respects the scientific process, I'm concerned by some of the attacks on the IPBES conclusions. Recently, during the Natural Resources Committee hearing, some people didn't like the results and seemed to try to poke holes in the process to get rid of conclusions that didn't suit them. However, anyone who wants to dig deeper can see that this was a rigorous and respectable process. As a committee, we should play the role of helping to distinguish between false attacks on science and real instances of violations of scientific integrity. There are real examples where science is being suppressed, distorted, or indeed censored, and scientists are being harassed or retaliated against. I introduced the Scientific Integrity Act to ensure that every agency that funds science has strong scientific integrity policies in place. I invite all members who care about scientific integrity to join me in that effort. I also am equally committed to standing up for good, rigorous, peer-reviewed science. It was recently reported that the Trump administration is working to change the scope of the National Climate Assessment by cutting off review to 2040. The existing review looks out to 2100 and beyond. We know that climate impacts have great effect on biodiversity, and we know that if left unaddressed, climate impacts will get worse in the decades to come. With that in mind, will this new 2040 cutoff limit our understanding of the actual loss of biodiversity?
Yes, without any question. We need to look at all plausible futures out to probably 2100. Climate change is accelerating, and even with the Paris Agreement to try and limit climate change, much of the climate change will still occur after 2040, not only affecting biodiversity, but affecting food security, water security, human health, etc. So to try and limit a projection to only 2040 does not make good scientific sense, and it will absolutely harm informed, evidence-based policy making.
Thank you. And Dr. Brauman?
I'll also note that much of the infrastructure that we build, and indeed many of the decisions we make, we certainly hope are going to last beyond something like 2040. And so building those to design specifications that take into account what the world is most likely to look like in the future is critical.
So I thank you both for your response to that. And oh, sure, Dr. Porter.
For coral reefs, the 2040 does not change the assessment at all. All of the things that I've described will occur before 2040.
Okay, thank you very much. With that, I yield back, Madam Chair.
Thank you very much. Mr. Posey.
Thank you, Madam Chair. Among its many concerns, the IPBES report specifically lists the conversion of undeveloped land into farmland as something that we should be particularly concerned about. Obviously, we need to continue to feed billions and billions of people, and American agriculture producers lead the world in growing more on less land than ever before. As the world leader in food production, it's not clear to me that we should be concerned about land being converted to farmland. My concern has been that in this country, as well as other parts of the world, we are devoting an increasing amount of land and resources to non-food crops, such as ethanol. Simply put, should we be growing corn for food rather than fuel? Question, your response.
That's a great question. I can tell you what we know about production. And what we know about production is that globally, we actually produce more than enough calories to feed the world today. And yet there are people that go hungry. And this is very much because we are diverting food crops to non-food uses or to feed. It's beyond the scope of this report to say what the decisions that we should make, but we certainly can talk about what the implications of the decisions that we are making or that we might make are. And what we clearly see is that it's the increase in consumption, particularly increasing consumption of meat, that is really driving much of this expansion of farmland at this point, because we do have plenty of farmland and we do grow crops very efficiently here in the United States.
Thank you, Dr. Watson. I see you writing like crazy.
Yes, I think the challenges in many developing countries is to improve the yield per hectare. In many parts of Africa, they're still only getting a ton of produce per hectare, where they should easily be able to get 3, 4, 5 tons with more agroecological practices, appropriate use of fertilizers, etc. So to feed the world, we don't actually have to double food production in the next 30 to 40 years. We have to double the availability of food. We waste 40% of all food that's produced in both developed and developing countries. So if we can reduce food waste, it moves us in the right. If we can get rural development in most developing countries, educate the women who are more often the farmers in development, make sure they've got some good microfinancing, we could actually not expand our farmland, but increase the productivity of farming. And indeed, copy some of the practices that are common here in the United States.
Mr. Goodwin.
Well, I think there's certainly common ground in some of these areas when we talk about land use change. But I'd also say that we already have provisions for some of those in the Farm Bill with the sod buster provisions to reduce some of those activities. But I'd also encourage you that those acres, the rangeland acres, are extremely important. They're extremely important at producing habitat, and we graze those with an animal that has the ability to utilize a food source that we can't. We don't eat grass. It does, and it converts that into a very wholesome protein that we do consume. And so we've utilized that grazing as a tool to benefit habitat for both the cow and the wildlife species. So, thank you.
Yeah, again, should we be growing corn for food rather than fuel? Dr. Porter?
No.
Okay. You think we should be doing it for fuel?
We should be, when we grow corn, I think it needs to be for food. I think there are other ways to address biofuels without converting corn to it.
Good, thank you. Dr. Montfort, care to weigh in?
No, I don't have an opinion on corn.
Okay.
Thank you.
Thank you, Madam Chair. I see my time's expired.
Thank you very much. Mr. McNerney.
I thank the chair, and I thank the witnesses. Pretty alarming testimony, folks. But first of all, I'd like to introduce a Foster graduate that is tailing me today. And today, this is Foster Day. So, Erica Hickey, would you please stand up? And we're having a lot of foster youth with the blue ribbons today. Please give them some consideration today. Dr. Brauman, one pathway of achieving transformative change is addressing biodiversity loss by improving freshwater management, protection, and connectivity. California has long been a leader in innovative in energy and technology, and now we want to apply that innovation to water modernization in our water systems. The report says that biodiversity is central to water quality and security. Can you expand on that?
Absolutely. So the bottom line for that is that what we put on the landscape ends up in our fresh water. And so having biodiverse watersheds with functioning ecosystems where we're seeing filtration of water and regulation of water as it gets into waterways is critical. Once fresh water is in these rivers and lakes and streams, then we also see cycling of nutrients and lots of other different kinds of potential contaminants by both the plants and animals that are in the freshwater systems themselves. So altogether, what we see is that these freshwater systems are much healthier when we have active flora and fauna.
I've seen demonstrations in Seattle of road runoff going into systems, and if it just is allowed to sit for a while, it refreshes itself, and fish can live in it. If it's immediate, the fish die. So I think that's a good point. Dr. Watson, your report says that the biodiversity and conditions that support it also play a role in regulating climate. Would you just say a few words about that?
Well, there's no question about it. If we can keep carbon in both above and below ground biomass, it effectively stops it getting into the atmosphere. So one of the real challenges is how can we restore degraded ecosystems? How can we reforest degraded ecosystems, and how can we afforest systems with native vegetation? And so if we can manage our land properly, including the soils very much, we can actually keep the carbon, or much of the carbon, in the soils and in vegetation, rather than in the atmosphere where it causes human-induced climate change. So there's no question whatsoever our ecosystems play a key role in managing at least the fluxes of carbon dioxide.
Well, following up on that a little bit, Mr. Good, when I'm intrigued by what I'd call carbon farming, could you describe what that would be and how it could be profitable?
Well, I think when we look at CO2 or carbon, most of us think about CO2. There's CO2 in the atmosphere and the terrestrial vegetation, but there's more in the soil than in both of those combined. And as a producer, that's where we have our greatest impact. And so And the term carbon farming is about increasing the organic matter in the soil. And if as we increase the organic matter of our soils, we also get these other soil dynamic properties that benefit us from an ecological functional perspective. And so that's where we gain our inputs, is within the production systems that we currently operate.
Can it be profitable, in your opinion?
Most certainly. Most certainly.
So that's a great tool in our fight against climate change, is absorbing carbon into the soils.
Yes, sir.
Dr. Montfort, what chances are there of coordinating infrastructure investment and biodiversity planning?
Well, in terms of biodiversity in the future, it's absolutely essential that there be better coordination across different sectors that have an impact on the environment. Too often, what ends up happening are conservation organizations and wildlife departments within governments will talk to one another, but other sectors that are often, especially in the developing world, much more influential or powerful are not at the table. So I mean, if you're trying to manage a system or implement a new policy and you only have, the poorest wildlife department present and not the Transportation Ministry and the Health Ministry and the economic advisors and so on present, it's unlikely you're going to have good policy come from that. So solutions really are possible. In our case, we work with oil and gas sector, for example, on doing biodiversity assessments before, during, and after linear pipeline developments, for example. We work with landowners who work, we have a whole program on working land and seascapes where we have our scientists are working with large landowners and trying to understand how can they make money and sustain native biodiversity on their soil, for example, on their property. And a third example involves wildlife, sustaining wildlife in human care. Zoos simply don't have enough room, and so we work with, in Texas, for example, large ranches that private landowners are partnered together in something called conservation centers for species survival. So we recognize that conservation success will only be achieved when you bring in the stakeholders that control most of the resources, and that's governments and private sector entities.
Okay, thank you. I yield back.
Thank you very much, Mr. Gonzalez.
Thank you, Madam Chair, and to the witnesses for being here today. It's great to hear about the interconnectivity and role that biodiversity plays in our global environment. I was particularly interested to hear about the positive impact that biodiversity has on our economy, encouraging job growth in a variety of fields. One great example happens in my backyard, and that's with respect to the Great Lakes in Northeast Ohio. Besides holding 18% of the world's fresh water supply, the Great Lakes support more than 1.5 million jobs and generate $62 billion in wages, much of which is Northeast Ohio based. Great Lakes have produced a $7 billion economic activity return on investment, and it's important for us as Congress to continue to invest into resources like the Great Lakes to reduce biodiversity loss. Dr. Watson, in your testimony, you discussed the interconnectivity of biodiversity and how best practices need to be incentivized worldwide to enact transformative change. Can you discuss how countries can undertake this task while also maintaining steady economic production, for instance, in agriculture? How can farmers overhaul their current process while still maintaining profitability?
Yeah, the first thing that we say is we need to be very multi-sectoral. In other words, you can't look at agriculture in isolation of energy, transportation, water, etc. So in any government, if we really want sustainable production and use of biodiversity, we need to make sure we get all sectors involved and all ministers involved. Having finance ministers involved in setting policies that are multi-sectoral. We need to also make sure we get all stakeholders involved. In other words, not just governments, not just the private sector, not just NGOs, but everyone together. We need polycentric governance at all scales. There is actually no doubt agriculture throughout the world can be much more sustainable. We don't need to extensify. We need to use good agroecological processes. And so there is, in my opinion, we can feed the world and save biodiversity and feed the world in a cost-effective way. As I mentioned earlier, reducing food waste is just one factor. But it's basically in developing countries, it's rural development. How do you allow the farmer there to develop a productive farm and actually get their produce to market? So you need roads, you need infrastructure, you need microfinancing. But the transformative change also says we need to look at our economic structure. GDP is a good measure of economic growth, but it's not a good measure of sustainable economic growth. The World Bank and many others talk about the 4 factors of wealth: natural capital, human capital, social capital, and built capital. We need to start to bring into our decision-making the value of nature in our decision-making, and it complements the use of GDP. Also, we need to look, to be quite honest, at some of the large subsidies throughout the world, agricultural, energy and transportation, that are often very, very harmful to biodiversity. So we need to look at how do you have incentives for sustainable production and try and eliminate many of these harmful subsidies.
Gotcha. And then following up, your testimony, you suggest that South America, Asia, and Africa are in the most danger of being affected by biodiversity loss. Can you elaborate on why this is and whether current policies in North America and European countries have been more effective in combating biodiversity loss? And I realize we're talking about 2 totally different economies, right?
Actually, even North America and Europe have not been as successful as we would hope in trying to protect biodiversity. Every country in the world signed up to the so-called Aichi targets. There's 20 of them. What we found in our analysis is we're making progress on about 4 of them. Some of them we've even gone backwards in the last 10 years since the agreement in Japan. The reason biodiversity can most affect certain people in developing countries, poor people are more dependent on biodiversity, nature, than we are in, say, North America and Europe. And so many poor people are quite vulnerable to loss of forests, loss of wetlands, loss of grasslands, etc.
And then I guess my final question quickly with the 30 seconds I have. So a lot of what you're referring to is happening overseas, outside of our borders. What can we as the U.S. government, or what should we be thinking about?
Well, through our aid policies, we can certainly work with developing countries, transfer of knowledge, projects that show how you can be sustainable. So US aid could play a very key role in showing how you could have sustainable agriculture, sustainable energy. All of that would go a long way to making a more sustainable world and protect biodiversity.
Thank you, and I yield back.
Thank you very much. Ms. Fletcher.
Thank you very much, Chairwoman Johnson and Ranking Member Lucas, for holding this hearing. Thank you to the witnesses for your testimony. It has been really interesting. I have jotted down numerous things to share, and I do want to follow up on a couple of questions. But first, I have a document that I do want to introduce for the record. The Theodore Roosevelt Conservation Partnership has prepared a statement that outlines what biodiversity loss, climate change, and habitat fragmentation means for hunters and anglers. And I ask unanimous consent to enter the TRCP statement into the record. Thank you, Madam Chairwoman. And that may be a place to start. Dr. Montfort, we've heard a fair bit today about some of the challenges that wildlife is facing, including disease, invasive species, habitat loss. What resources do you think would be most helpful to federal and state wildlife managers who are trying to confront the magnitude and complexity of the threat?
Well, the types of, I think, knowledge is something that needs to be shared, and as we learn about new approaches and techniques, we need to make sure that we're sharing those. I mentioned the Virginia Working Landscapes program that we work in Northern Virginia. Basically, we don't have all the answers at the Smithsonian, but we know that together, collectively, we manage property. Out in our Front Royal facility, for example, we have 3,200 acres. So we're a large landowner and manager. We're trying to learn from each other by sharing knowledge about what works and why, and how we can take things to scale. This is sort of the theme of our Earth optimism idea. How can we learn from one another to do better and to find solutions? And so in a case like that, we serve as sort of the intellectual hub. We bring the community together and we share experiences, and we provide access to external advisors and partners, much like an extension agent might provide. So I think basically boots on the ground, working with people in the communities, in the areas that you're trying to affect change is really important, whether it's here in the U.S. or abroad.
Terrific, thanks. Another topic that we've covered this morning that I'm particularly interested in, because I'm from Houston, so represent a lot of folks down in Houston where we're dealing with, of course, many of the impacts of climate change in terms of our weather, in terms of storms, and also as we're confronting our energy future and what it looks like. So we're particularly interested in climate and climate change. And the topic of carbon sequestration is really important. It's one of the things that I think people are looking to. And so I think, Mr. Goodwin, this came up in questions to you about carbon sequestration and also sort of carbon farming. And I think it also came to you, Dr. Brauman, about is this something we can measure? So we've heard some innovative and interesting ideas in my district about coming up with a market-based sort of carbon sequestration system that would use, for example, existing wetlands or preserving native prairie. And I'd love to get your thoughts on some of those kinds of options, how we could measure it and how we could move from where we are to having a real market-based system that would support that kind of preservation and increase biodiversity.
So there actually are lots of really exciting models for this. Some of them are called payments for ecosystem services, and they really involve two parts. So one of them is really being able to measure what's the benefit. And there's lots of things we know. I work with the Natural Capital Project. We're doing lots of cool work, really quantifying this stuff and looking at where on the landscape it is. It's something that we need to do more of, but it's something that we know enough to start now. The other piece that's really important is having the institutional infrastructure to actually make a payment to receive things. And there's really neat models that are beginning to develop, everything from water funds, which are becoming more common all around the world. There's some actually here in the United States where water users are paying upstream residents to manage their lands in different ways to improve water. And what's really great about the ecosystem services framework is that it lets us plug into a lot of these existing market-based mechanisms.
Terrific, thank you. Mr. Goodwin, do you want to weigh in?
Yeah, absolutely. Certainly, I think there's opportunities for us to look at solutions for incentivizing carbon sequestration and other ecosystem services. The fact is, for thousands of years, producers have been compensated for two ecosystem services, food and fiber, yet they're producing clean water, they're sequestering carbon. I think it's an opportunity for us to not look at the moral sense, but just provide an opportunity for market-based solutions, not federal regulation, but instances like the Ecosystem Market Consortium that's currently being put together. They're looking for, they've brought together NGOs, they brought together large corporations to find solutions that are providing carbon, soil carbon, water quality, and water quantity solutions for farmers and ranchers. The problem with the measurement is it's expensive. And so we've looked at solutions like spectral solutions, like looking at mid and near mid-vis spectroscopy. So we have to find ways and technology is going to help us move in that direction to limit the MRV costs, and so that we could have more of that money not going back to a middleman, but going back to the producer.
Great, thank you. I see my time has expired. I thank you, and I yield back.
Thank you, Mr. Lucas. You want to ask any questions? Okay. Mr. Caston.
Thank you, Chair Johnson. Thank you so much to the panel for being here today. So I often say that climate change is the existential threat to our species, and the IPBES report makes it clear that our species is not particularly unique in the sense of that risk, other than the fact that we think we're unique. With 25% of the species at risk, I think we delude ourselves if we think we are not a part of that ecosystem and impacted by it. Dr. Brauman, I think you said that a 2-degree temperature rise, about 5% of the species are at risk, if I was noting that down. Or is that Dr. Watson? Okay. And I realize this is imprecise, but can I extrapolate from that about 20% of the species loss you see is attributable to climate change, or is that too sloppy an estimate?
I think the problem is all of these drivers, whether it's land use change, pollution, overexploitation, they all interact with each other. And so climate change is one of the threats. It changes species composition, populations, it threatens extinction, it moves the boundaries. So we know that climate change, while it has not been the biggest driver in most systems today, is an increasing driver. So this is why we argue that you have to look at both climate change and loss of biodiversity together and recognise what are the policies, practices and technologies that can be win-win for both biodiversity and climate change, and not win-lose, because there are some trade-offs.
Well, here on that. Let me sort of try to ask the question from a different direction. On the Select Committee on the climate crisis, we had a panel 2 weeks ago, and I asked them, if we eliminated all CO2 tomorrow, how much sea level rise is baked in? And the answer was 2 feet. If we eliminated all CO2 emissions tomorrow, how much species loss is baked in?
To be honest, I can't give you an answer, but we'll try and find an answer for you and submit it to the record. We'll talk to some of the people that will have done some of that type of modelling.
Okay, and I'm all for the win-win, and I agree that that's a lot easier, but I want us to be realistic about what we're looking at here going forward and the consequences. Mr. Goodwin, I really appreciate all your testimony on agriculture. I come from the energy industry, and I think in some ways the energy industry is easy to decarbonize. Agriculture is much harder, and I appreciate the good work you're doing to get that done. Can you help me understand what's the range of reasonable carbon reductions we can expect from agriculture? You know, if you look at arable acres of land or whatever the unit, how many tons per acre can we realistically expect to reduce if we implement all the best practices you've got in mind?
Well, I think we start with one farm at a time. I think we take, a lot of times we take this global look and try to solve the problem globally when these issues are going to be solved locally. So we start at one farm at a time. And so the key here is to stop making farms on ranches or employing these practices that provide a source and turn them into a sink. Right.
So I totally agree with that. I asked the question because as we think about what type of research programs we're going to fund, what types of measures, I'm trying to understand, as my old head of engineering used to say, is it bigger than a bread box or is it smaller than a bread box? What is the potential, and I don't know, Dr. Brauman, if you want to comment on this, because I know you talked about some of this research with perennial crops. Mm-hmm. How much carbon potential are we talking about that we could sequester in the ag sector? I think we know that number for other sectors. I've not seen a really good estimate for what that is in the ag sector.
I think there has been some work done on this, and I don't have that number on me, but I will certainly find it and submit it for the record. What we do know is that nature is really the only sink for carbon. A lot of that is in the ocean. Some of it's biochemical processes, but it's also about ocean algae. And then what we do on the landscape, which is, growing trees and growing roots, is really the only other place that carbon goes. So in terms of research and the need to better quantify those numbers and also find ways to improve them is critical.
Okay. So I've heard, and I don't know if this is true, I've heard estimates around 1 to 2 tons per hectare, but I don't know that number includes reduced fertilizer inputs where there's so much of the entrained CO2. Which brings me back to Mr. Goodwin. When you look at farms that have taken this one farm at a time approach, presumably they got fewer inputs. They're getting maybe another crop per season out of the land. What is the economic value to that farmer? Is this purely charitable, or does the farmer save money from reduced inputs or higher yields as they go through these practices?
Certainly, they have increased economic opportunities to decrease the input. A penny saved is a penny earned, right? So if we're not applying those inputs, we're saving money. We've got examples of producers that we work with that are out yielding their current county cohorts and their county averages with limited to reduced fertility, and providing sequestered carbon. And that 1 to 2 ton number is not out of the question. Certainly not out of the question for a majority of the farms in the United States.
Well, I see I'm over my time, but I'm delighted that you ended with that, and I swear I didn't set this up. We started and ended with a win-win. Let's stay focused on it. Thank you. I yield back.
Thank you very much. Ms. Hill.
Thank you, Madam Chair. I was just reading a UC Santa Barbara study last week that quantifies the effects of political lobbying on the likelihood of climate policy enactment. It finds that $700 million in total lobbying by corporations around the Waxman-Markey bill reduced the bill's chances by 13 percentage points, from 55% to 42%, representing $60 billion in expected climate damages due to the lowered chance of enacting U.S. climate policy. The money isn't the only cost, of course. Human health and well-being are also heavy costs, such as loss of life and destruction through natural disasters like wildfires. Last year, we saw a number of shocking fires in my home state of California. 2 days after Election Day in last November, the Woolsey Fire ignited and burned in Los Angeles and Ventura counties. It destroyed 1,643 structures, killed 3 people, and prompted the evacuation of more than 295,000 people. Throughout California, communities remain devastated and are trying to rebuild today. There's no question that one of the key biodiversity drivers, climate change, is enabling more intense wildfires in the West. While a certain measure of wildfire is good, quote, good, for wild areas so long as people and property can remain safe, in California, we're seeing regions staying dry for so dry for so long that it's clear that they are not bouncing back. Dr. Watson and Dr. Brauman, can you talk a little bit about the relationship between biodiversity and wildfires and how a changing climate can impact that relationship?
The interaction between biodiversity and wildfires is incredibly complex. And part of the reason is because many of the responses take place over long but varying timescales. And so the heterogeneity in landscapes that fires produce is great for biodiversity in the long term. We see forest stands and also grasslands of different ages with different species. There are many species, especially in California, that actually only regenerate with fire. They need the heat in order for the seedlings to grow. We also see in the short term that there's often devastating effects to biodiversity, both in terms of the vegetation, but also the animals who are either killed or displaced, and that it can take a very long time for some of that to come back. And one of the reasons that connectivity, thinking about infrastructure, and really thinking about all of these drivers together is important is that if those animals, if pollen and seeds and seedlings have somewhere to go, then the impacts are much less. But if there's only one forest and it's hemmed in certain ways, then there's not. And so the impacts can be much greater. And the other thing that we see is that with the dryness and with decreased fires and therefore higher fire intensity, that the impacts are bigger, the impacts are longer, and it's not just on biodiversity, but that's when we start to see really nasty flooding, really bad for water sources, all kinds of problems. And so, understanding, putting the time and money into understand these complex systems and manage them better is critical.
Dr. Watson, do you have anything to add?
Not so much on the wildfires, but your first point about vested interests. One thing that we pointed out in our report, and IPCC pointed out in there, that effectively to have the sort of transformational changes that we need, both to limit climate change and to save biodiversity, there will be some key vested interests that will fight against removing some of these perverse subsidies, against payment for ecosystem services. And so and also the power symmetries between different lobby groups. So your first point is a really crucial one that we brought up in our document, that we need to deal with power symmetries, we need to deal with vested interests and get everybody on board to see that in the long term, it's in everybody's best interest to deal with climate change and to deal with the loss of biodiversity.
Absolutely. Should we be addressing wildfires differently than the past, given your comments about biodiversity and how, it's important in terms of burn areas are important? And also what types, you mentioned the research that we need to put in the money to understand this, but what types of research are needed and how do we need to be thinking about funding it?
So there's been a really great evolution in fire management as we have learned more. It's been very responsive to how we understand this, and I am confident that we will continue to evolve our management strategies as we learn more. And so, yes, there will need to be changes. Certainly smaller controlled burns, actually very similar to the kind of grassland controlled burns that Mr. Goodwin was talking about, are very likely to be important. Understanding some of the more subtle processes that happen, so things related to soil processes, water, as well as the really kind of big species and big trees issues, I think are going to be something that's quite important to understand, especially as these ecosystems regenerate and we want them to keep delivering the services that are important for us.
Thank you so much. I yield back.
Thank you very much. Dr. Foster.
Thank you, Chairwoman Johnson and Ranking Member Lucas, and all of our panelists for joining us. I'd like to bring up, I guess, for not the first time here, the issue of Asian carp, which is very local to my issue. You know, this Asian carp have already wreaked environmental havoc up and down the Mississippi River watershed, and it's currently threatening the Great Lakes and every river connected to them. The last line of defense actually is in my district, near the Brandon Road Lock and Dam near Joliet, Illinois. The U.S. Army Corps of Engineers has finalized and approved on a proposal of about $778 million, which calls for measures such as an engineered channel with an acoustic stitcher, air bubble curtain, and an electric barrier. There's currently a temporary electric barrier in place, which is the best we have. But not only is this barrier designed to prevent the catastrophic introduction of Asian carp into the Great Lakes, but it's also intended to continue to allow for commercial navigation, which is why it is complicated. And it's now up to Congress to authorize funding for the Army Corps to go ahead with this plan. And you know, in fact, the WRDA bill that supports this funding is coming up for a vote this week in the U.S. Congress, and I hope that my Republican and Democratic colleagues come together to vote for the WRDA bill to prevent this catastrophe. And so I guess you're already on the record as saying Asian carp are highly destructive. I don't think that's... so one of my questions is sort of the longer-term research in dealing with invasive species. There are ideas out there like gene drives, like the release of sterilized males, which you know, have been successful in some species. What is your take on that? Are these technologies just ultimately too dangerous to pursue? Are they things that we have to pursue because of the problem with invasive species?
So I'm lucky enough to live further up the Mississippi, where we actually closed one of the locks and dams to keep the invasive carp out. What's clear is that addressing issues of invasive species once they've already arrived is always going to be expensive and painful. So the very first thing we need to be paying attention to is managing better to make sure that the invasions and the introductions don't happen in the first place.
Right. Or we could just send, in the case of Asian carp, just send the bill for all of this to Arkansas, which in their wisdom introduced this into ponds that flooded.
In terms of the specifics of the right way to address this, there's a lot of them, and I'm not familiar with the specifics of those, except to say that these kinds of responses are always going to be riskier than simply not introducing these species in the first place. There are a wide range of different kinds of responses. Asian carp are not considered invasive in Asia, and in part because people like to eat them. So as we change public perceptions, there's all kinds of possibilities out there. But I, again, would really reinforce that being more strategic about making sure that we don't have these kinds of invasions is going to be important.
Yeah, Dr. Watson?
Just a minor comment. I'm not at all an expert on Asian carp, but one of the next big IPBES reports will be on invasive alien species. There will be a whole assessment which will come out in about 2.5 years, specifically looking at the whole issue of alien invasive species.
Well, and I hope you also look at countermeasures and research into countermeasures, because these things are obviously double-edged swords, but you know, potentially great and very dangerous. And I'd also like to bring up the long-term future of land use for farming. You know, I'm not sure I'm completely on board with the narrative that, you know, there's this ever-increasing demand for food and cropland. You know, the population's projected to hit the peak around, I think, 2070 or sometime like that, and decrease afterwards. Yields on crops like corn have been doubling every 20 years, so that, you know, if you only need a certain amount of crop, that will cut by factor two the amount of land you need. There are technologies like artificial meat where, you know, in principle, these impossible whoppers that are now going to be nationwide at the end of this year use up, I think, about 1/16 the land per hamburger. And so that, you know, it may be that actually, you know, the need for land dedicated to farming will actually peak even earlier than the population and start declining. I was just wondering if you have, you know, is there anyone who does those sort of projections and looks at the economic impacts of that?
There are projections along these lines in the IPBES report. We actually looked at a number of scenarios, and some of those involve sustainable futures that include a combination of on-the-ground technologies as well as reduction in per capita consumption. And so, yes, you're absolutely right. There's lots of potential for not needing to expand farmland as we both change our diets and also as we increase yields in places where there's lots of opportunity for increasing yields.
And I guess I haven't even mentioned, these factory farms in the sense of growing crops under grow lights where you can get 6 crops a year and don't have the shipping cost to the cities. So it'd be nice to have a forward look at what agriculture looks like 100 years from now, so we know what technologies to invest in. And I think I'm over time, and happy to yield back.
Thank you, Dr. Foster. Mr. Byer.
Madam Chair and Ranking Member Lucas, thank you very much. This is fascinating, especially in light of the UN's report on the accelerated loss of biodiversity. I am very grateful and impressed by the very clear direct drivers which showed up in a couple of your reports, that changes in land and sea use, direct exploitation of organisms, climate change, pollution, and invasion of alien species. And it's very clear that we're destroying the core of our livelihood, food, health, and economy, and that we are in grave danger. As a member of Congress, I'm always struggling for what is it that we can do? What are our direct pieces? Let me quote the wonderful physicist David Park, who said, "Physics is as much a trait of mind as it is a body of knowledge. It is the imperative, simplify." So to simplify, let me lay out 4 things. First, on carbon. We know, and I think this Congress will grapple with carbon pricing, some way to make carbon much more expensive and stimulate everything else, including changes in our behavior. And there are some really good bills. Jerry McInerney, who was up here, has the lead on one of the ones on carbon sequestration. And once again, there are dozens of experiments around the world right now on taking carbon out of the air, out of the water, out of smokestacks. I was proud to introduce the Wildlife Corridors Conservation Act last week with Senator Udall and Congressman Vern Buchanan to ensure that it's really to incentivize state and local governments to create corridors so that native wildlife, including fish, animals, plants, butterflies, continue to migrate, adapt, thrive in the face of increasing threats. It just gives these species a fighting chance, and it's a critical step forward. So those are a couple of concrete things. And by the way, I'd like to ask for unanimous consent to submit a statement from the Wildlands Network on habitat connectivity without objection. But Dr. Watson...
Without objection, so ordered.
Thank you. Dr. Watson, Dr. E.O. Wilson, who shows up in some of these, in reacting to Dr. Montfort's notion that we're going to build 15 million new miles of roads by 2050, has talked about half Earth. In fact, his last book is that we should devote half of the terrestrial planet to half Earth. What do you think, and what's the way forward? How do we, as members of Congress, begin to make that happen?
Yes, we didn't address that directly. We did talk about protected areas. To me, the half-Earth concept, I think we'd have to define what you mean by it. People live all over the world today. So the question is, how do you integrate people into a protected area? What we did say is that while we've got a lot of protected areas, much of the key biodiversity is not inside our protected areas. Second, many of the protected areas are not well managed. And thirdly, none of the protected area designs take into account climate change as species move and as boundaries of ecosystems move. What we pointed out was, yes, we should focus on protected areas with appropriate design and corridors, but we also have to recognize that much of biodiversity will always lie outside of protected areas, and therefore we have to integrate biodiversity concerns into agriculture, timber, transportation, forestry, etc. So it's a combination of how do we do multi-sectoral planning, recognizing you don't only think about the economics of a project or a technology, you think about the implications for biodiversity. So yes, I think it makes sense to expand the protected areas, both marine and terrestrial, but at the same time, I don't think you can rely on protected areas to really do the job.
Okay, great. Thank you
May I
very
make
much.
a comment on that?
Yeah, yes, please, Dr. Montfort.
Well, first of all, this is the Science Committee, so I'd like to make a plug for science. And The Smithsonian is a knowledge institution, and I would point out that we know very little about biodiversity and how much there is that exists and how it's distributed in space and time. And we're discovering new species all of the time. Just at the Natural History Museum every year, they discover between 300 to 400 new species every year. There are thousands of species sitting, waiting to be identified, for example. So we know that there's great diversity, but we need to know more. We don't even know where organisms move. Most organisms that we're trying to save or we're talking about with biodiversity, we don't even know where they go throughout their life cycles. So we need fundamental knowledge to be able to make good decisions.
Right. Thank you very much. Dr. Brauman, I noticed that you had the PhD in interdisciplinary program in environment and resources. And picking up on what Dr. Montfort said about 200,000 years to get to 1 billion people and 200 more to get to 8 billion, there's incredibly little conversation on Capitol Hill about population, whether it peaks out at 2070 or not. How do we begin to have a responsible conversation of what the carrying capacity of the planet is, especially as it relates not just to water, not just to land, but to biodiversity?
What's critical about the idea of carrying capacity is the question of what does per capita consumption look like? And with animals that we study, it's not so hard to figure out how much they need to eat. But with people, it turns out that you don't actually drink very much water every day, and yet the amount of water that people need is bigger than that and varies widely around the world. And so it's almost impossible to have a conversation about carrying capacity without talking about consumption and per capita consumption.
Great. Thank you very much. Jerry, yield back.
Thank you very much, Ms. Weston.
Thank you, Madam Chair, and thank you to the members of the panel for coming out today. I have really enjoyed your testimony, and although I'm a little bit fearful and frightened about our future, I also feel some optimism about our prospects. Dr. Montfort, I would be, if you'll have to excuse me because I do have to take a moment to engage in a little bit of fangirl action for the National Zoo and the Conservation Biology Institute. My district, I represent Northern Virginia here in Congress, and I am also the mother of 2 kids who are now 14 and 16 years old, but both of them attended zoo camps. We have spent literally thousands of hours, I think, in the National Zoo in one way or another, and we always looked forward to that Saturday in fall when we could go to Front Royal and check out the Conservation Biology Institute. What you guys have done with the breeding programs for the scimitar horn oryx and the Schwalski's wild horses is amazing. Although I know you're limited by the genetic stock that you have, what you have managed to do with those populations is incredible. But I would also note that while the brush-tailed batong are very adorable, I would be remiss if I didn't use my opportunity to be speaking with you to express my disappointment that the Smithsonian and the National Zoo no longer houses or breeds the black and rufous giant elephant shrew. Those were always a fan favorite, and they certainly were mine. But I thank you for everything that you have done and for your testimony here today. Dr. Porter, I want to thank you for your passion. It was clear in your presentation how passionately you feel about this, and I was really glad to hear it because I have a brother who was a non-commissioned officer in the NOAA Corps, so I was glad to see that you participate in some of those NOAA research voyages. And my siblings and I are all scuba divers. I think my first checkout dive was about 28 or 29 years ago. And just in that period of time, what I have seen in terms of the degradation and the damage to the Caribbean corals is really frightening and disappointing to me, because I want to be able to take my kids on scuba diving trips someday and show them the beauty of the undersea world and those reefs, and I'm not sure they're going to be there. So you spoke a lot about the increase in temperature as being the biggest threat, and
Yes.
Clearly that's the case. But can you speak a little bit about ocean acidification? Because that's something this committee is working on at this time and may be able to hopefully have some good results. I see Ms. Bonamici is back, and she has taken the lead on that. So if you can speak a little bit about acidification and the impacts that has as well.
Thank you. CO2 has 2 impacts on the ocean. One is to serve as a blanket to raise its temperature. The other is to dissolve into the ocean and acidify it, because CO2 causes water to be acidic. And I focused on CO2's problem with temperature because that's the first one that's going to get coral reefs. But the second one is exactly what you said, ocean acidification. We have a technical term for these two problems in coral reef ecology. They're called the evil twins. And we're worried about both. Research is going on. Thank you for understanding that. And further research on ocean acidification, which is done by all these agencies, is extremely important. Thank you.
Thank you. Now, my district starts just outside of Washington, D.C., but it does go out pretty far west into some pretty rural agricultural communities. And I recently met with some farmers in my district, some of whom are starting to implement no-till and cover crops to improve their soil quality and soil health. Many of them were also doing this for the first time. So that tells me that there is a new understanding of the need for this and a desire among agricultural producers to do it. But we don't talk about soil health really just writ large the same way that we talk about clean air or clean water, but it's just as important in my mind. So in general, Mr. Goodwin, do you think soil carbon health has gotten the right amount of attention in the past? And if not, what can we do to increase the attention on it?
I don't. I certainly think anytime we can talk about ecology and anytime we can talk about how carbon works in a system, most people hear CO2, they're afraid of it. But carbon is the actual driver in most ecological systems. That's what plants feed on. And so we have to do a better job of telling our story, most certainly, because those producers that are making those changes, they have to believe in it. And when they do believe in it, it takes about 3 years to change practices, to change that practice. I mean, we're talking about changing equipment, everything. And so once that has been made, in my 20 years of working with producers on the ground, I have yet to meet one producer that's made this significant change, has been successful, and then's gone back to conventional ways.
Thank you very much. And so it's an issue of convincing them that it's best for them and for the best practices, but then also maybe providing some incentives to make it possible for them to make that transition. Is that correct?
Yes, ma'am.
Okay, thank you very much. I see my time has expired, so I'll yield back.
Thank you very much, Ms. Bonamici.
Thank you very much, Chairwoman Johnson and Ranking Member Lucas. I'm happy to be able to join you from the Education Committee. The findings of the IPBES global assessment are stark. We know that the health of our ecosystems is rapidly deteriorating, and we don't want to get to the point where the consequences will be irreversible. And I'm glad that the report recognized a sort of multi-coordinated approach to this and all the drivers of biodiversity loss. I see it as, not only the need to reduce pollution, control invasive species, address the climate crisis, sustainably use our land and water, protect natural habitat. So it's really going to take all of that together. Dr. Watson, you recently told National Geographic that your biggest personal concern is the state of the oceans. As the co-chair of the House Oceans Caucus, I wanted to call attention to this statement as we recognize National Ocean Month and Capitol Hill Ocean Week. Our oceans are often left out of the equation when we're responding to the climate crisis, but they're home to most of the life on the planet, and our response to the biodiversity crisis has to put our oceans at the forefront of the solution. So in your testimony, you mentioned that climate change is projected to become as important or more important than other drivers of biodiversity loss in the coming decades. Oceans are absorbing more than 90% of excess heat trapped in the atmosphere from greenhouse gas emissions, and of course causing harmful algal blooms, which produce acid that's harmful to shellfish like our Oregon Dungeness crab, also may be poisonous to humans, as we know. And as HABs decompose, they create the hypoxic dead zones where marine life cannot survive. So last Congress, we reauthorized the Harmful Algal Blooms and Hypoxia Research and Control Act, but hypoxia and harmful algal blooms are often conflated at the federal level. So I'm working on legislation to address these issues separately. So is there a need or opportunity for dedicated federal funding for hypoxia mitigation strategies to protect marine species, and what should Congress be doing to support those efforts?
the answer is basically yes to your question. The reason I say that the oceans are, I mean, I'm concerned about all ecosystems. The concern about the oceans at the moment is we've probably spent less attention on the oceans. The plastics in the oceans, we've got to stop it. Most of the plastic is coming from Southeast Asia and the big rivers in Southeast Asia, so we have to worry about the plastics and the microplastics. The overfishing throughout many parts of the world. The US actually is probably one of the better countries in the world in managing fisheries, but in most parts of the world, we're fishing further from shore, deeper into the ocean, smaller and smaller fish, so we've got a problem of overexploitation. Coral reefs, as you've already heard from Dr. Porter, unbelievably sensitive, not only to climate change, temperature, and ocean acidity. At 1.5 degrees Celsius, and we're already at 1 to 1.1, maybe 10 to 30% of corals could survive. At 2 degrees Celsius, probably only 1% of corals could survive. And to be honest, a projection that I made, and actually been supported by much better studies than mine, is we're on a pathway to 3 to 3.5 or 4 degrees Celsius. The Paris Agreement, which wants us to limit it to 2 degrees Celsius and even more, 1.5, we're not on a pathway to 1.5 or 2. We're on a pathway of 3 to 4.
Right, I'm going to try to get another question in, too, to follow up on what you mentioned about plastics. Every minute, the equivalent of a garbage truck full of plastic is dumped into the oceans. According to the UN, it's astounding, 8 million tons a year. So I want to talk a little bit about microplastics, and I think this was brought up earlier, but to follow up, we're finding pieces of microplastic into marine life, blocking digestive tracts, altering growth, and in some cases killing animals and marine organisms. We don't know how long it takes for plastic to completely biodegrade. The estimates are like 450 years to never. I thank the committee for getting rid of the plastic bottles. We have cups, we have reusable water bottles. It's a step. But you're talking about many of the priorities of the Bipartisan Oceans Caucus with the fishing and plastics. But I'm working with Senators Whitehouse and Sullivan and Representative Young, the Oceans Caucus co-chair, on Save Our Seas 2.0 to take further steps to address marine debris. You're right, a lot of it comes from other places, but it is a global problem. The assessment found that marine plastic pollution has increased tenfold since 1980, affecting at least 267 species, 86% of marine turtles and 44% of seabirds and 43% of marine mammals. So what do we currently know about the effects of microplastics in our ecosystem, and what research do we need in the future? Looks like Dr. Porter wants to answer that one.
We know very little, which is unfortunate, but we do know that the microplastic particles, after there has been some degradation, are in fact more dangerous than the large particles that draw everyone's attention. Right. As I mentioned earlier, it is estimated that by 2050 there will be more plastic in the ocean than fish. I thank you for your service on the Oceans Committee.
No, thank you. And I see my time has expired. I yield back. Thank you.
Thank you very much. That's the end of our witnesses. But before we close this hearing, I want to thank all of our witnesses for testifying today, your superb group. The record will remain open for 2 weeks for additional statements from members or any additional questions the committee may ask the witnesses. Our witnesses now are excused, and our committee is adjourned.